right, it's time for another experiment. I want to do some more comparing of exposure rates. I think the more experiments that we do comparing the exposure rates, we'll get a clearer idea of which options are the best for us. So tonight I wanted to do the Bubble Nebula. And what I want to do is compare all of the different exposure rates, the 10, the 20, the 30, and the 60-second exposure rate. And then I want to record them for 60 minutes or an hour worth of recording. So I started this one and I had it set up on the 22nd. So that's the one I'll do first. So what I'm going to do is I'm going to record the time that it started recording. Then I will notate how long it took for me to gather the 60 minutes worth of exposures. And then I will change the exposure rate and then do those again and compare to see which ones are being the most efficient. It's probably a fairly good time to do an experiment like this because there's not a big bright moon. I think it's a 9% waning moon right now, but it's pretty small. And I think it comes up in the early morning in my area so that it's not interfering with what's happening tonight. So I have started this one. It's NGC 7635. And my goal is to collect 60 minutes worth of exposures at all the different exposure rates, and then we'll compare them as we go. So you can see here that I've already started and I have 2 minutes and 20 seconds worth of saved time so far. So I'm not going to take you through all of that because that would be an awful boring video for anybody to watch, but you can see it's kind of appearing there in the middle. And if I click this identifier, it circles it right there, the Bubble Nebula. And this one is a real pretty one. I really like this one. I found this one kind of by happenstance. I was recording and I just found a random nebula that I wanted to image. I didn't even really know what it was, and I put it up in a plan. And the first few minutes, this is what I saw, is what we're seeing right now, and it really just didn't look that impressive. But I, without a plan, so I went to bed and thought, oh, it's probably gonna be a dud. But then I woke up the next morning, and man, this is a beautiful nebula. And so this is what I wanted to try because I think doing an hour on each of those exposures, I do realize that is a short amount of time to do post-processing and, creating fabulous printable, mount on a board and hang on your wall kind of imaging. But for experiment purposes, an hour should be pretty good. But you can see it starting to materialize there, but it comes in fairly slowly. And so I thought this one would be a fun one to compare because it does come in a little slower. It's hard to compare the ones that just show up brilliant like Orion, within the first 10 to 20 seconds of exposure. It's a brilliant, beautiful nebula. And this one takes a little bit longer. So we might have to work at this one a little bit to get it really beautiful. But I think if we save an hour of each exposure rate, we'll get a good comparison. So that is my plan tonight. And I will record the time so we can determine the efficiency of the saved exposure rates, and we will compare from here. So I'll bring you back when I have some more results, and then we'll talk about them. I wanted to bring you back after the first imaging finished, just so that you can see what we're working on. This was the 20-second exposure, just because that's what mine was set up with when I turned it on. And so I'll change its exposure rate after this, but I wanted to show you this object. If I just click on here, it's saved the 60 minutes. And this is the Bubble Nebula. Isn't that neat? I just think that's pretty. I haven't done any editing or anything on this image at this point. I want to, I'll do some of that a little later on. Let me see if we can get it in here. We can denoise it. It takes about 15 seconds to run through the denoising. and we can do some minor editing. I won't save the minor editing or anything because I want to save them all with unedited versions. But I do like to darken the background a little bit. We can crop it, zoom in a little bit on that. We could change the color a little bit, make it more brilliant if we wanted. I really like the natural colors, but I do like to darken the background. Maybe we could brighten some things or darken. You know, isn't that neat? I don't know. I haven't seen a lot of this one online, but it sure is pretty. I do like it a lot. I'm not going to save those ones because I want them to all be consistent. So that's the first one at the 20-second exposure rate. And now I need to go into the Seestar, go to the advanced features, and I think I'll set this one up and start doing the 60-second one. I'm not going to be able to finish these in one night just because the saving rate hasn't been fabulous on the 20-second one, and that's usually the one I do well on. So who knows, it may take me forever to get this one. The 60-second one probably going to be worse. And so let's see how we can do. But I'm just going to turn it back on to that one. And I just wanted to show you this one and remind everybody that wants to do these kind of experiments that once it finds the target, it does have to do this image enhancing, and it's going to take a minute for every one of those second exposures. So up to 6 minutes it can take to do this image enhancing. And so you can't really just do them bam, 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 one right after another. You have to take into account that there's a little lag in imaging time as it image enhances and prepares the Seestar to image at a different exposure rate. But I wanted to just bring you back for that. I for sure I'm going to put up all of the exposures. It may take me a couple nights to gather all 4 of the options. And I think what I'll do at the very end is I will stack all of the images or exposures that I gather. So we'll stack 4 hours worth of exposures, because for those that don't know, you can stack different exposure rates together. Each exposure rate is just one image, and that's how the Seestar sees them. We can go into that deep sky stack and stack those. It doesn't pay attention really to the length of the exposure. It just considers each one an image. And so we will maybe do that at the end, and we'll have 4 hours of exposures that we can stack, and we'll see how that turns out too. But I just wanted to bring you back and show you what we're working on. And then I will continue imaging over the next night or two, depending on the clouds and everything. But this is what we're working on, and I'll bring you back when I have more results. So I did do these a little out of order, just because of how it was set up. So the first image I did was the 20-second exposure rate. It took me 119 minutes to gather 60 minutes worth of exposures. So that's a 50% save rate on the exposure rate. And this is the image that I got. The second image that I gathered was the 10-second exposure rate, and it took me 93 minutes to gather the 60 minutes worth of exposures. So that was a 65% save rate. And just as a note, I haven't done any editing. They have not been denoised or darkened or lightened or anything in the app. These are just straight off the Seestar without any editing. You can see that the image number 2, the 10-second exposure rate, the background is darker. That's just because I did it a little later in the night after my neighbors were going to bed, and the night became just a little bit darker. And so it's not a fabulous science experiment, but this will give us a good idea what we can expect for the different exposure rates. And just as a note, once I get them all on the screen and we talk about the save rates, I will enlarge the images a little bit more so that we can compare some of the detail in them. Sometimes when you enlarge them, because they're JPEG files, they deteriorate a little bit, but I'm hoping that they won't since there's 4 images. But I want to be able to deep dive into the details of the images for you. And then after we're done comparing all 4 and we've compared the enlarged version, I will stack all of the exposures that we've gathered for this object, and then we'll see how it looks when we stack them all. That is my plan. So the stats on trial number 3, which is the 30-second exposure, it took me 120 minutes to gather the 60 minutes of exposures. So that is a 50% save rate. It's exactly the same as the 20-second exposure rate. So that was kind of interesting. You can tell that this was taken later in the night than trial number 1 because of how dark the background is. And like all of them, no editing was done at all. All right, so trial number 4 was a bust. What I did is I set this one up. It was taking forever to even save one 60-second exposure. I ended up setting it up on a plan and letting it run all night, and then I figured I could just go through the exposures and figure out when I had 60 of them, and then I would know by the date and the time which ones would satisfy the 60 minutes that we wanted to collect. Well, it went over, well, let me start from the beginning. So I started it in one night. Then I turned on the plan that went all through the next evening, early morning. And I got up and I had 45 saved exposures over the entire night. It was, I think I had like 4 hours of runtime, and it saved 45 minutes. So then tonight I went and I added another, was going to run it and get another 15 exposures, and then we would have the 60 exposures. Well, it was a slog. It was saved one exposure in about an hour, and I still had like 14 to go, so I just stopped the plan. And then what I did is I just got the save rate based on 50 exposures instead of 60. And then I knew I didn't have one image that came from all of those because they were spread over 3 different imaging days. And so I went into the Deep Sky stack, selected the 50 exposures, and had the Deep Sky stack do the stacking of only those 50 exposures so that we could get something to compare. Well, this is what it came up with. And so it just really did not save anything. And so I'm going to eliminate that from our little test this time around and call that one a bust. It only saved at a 22% save rate based on the 50 minutes. And if I'd have continued on, that would have even been less because I was only getting one saved exposure in the course of an hour. And so it would have gone all tonight, and I probably still wouldn't have even finished. And so I'm going to eliminate that one. The 60-second one was a total bust. And so we'll eliminate that one. And so now what I'll do is I will take the first 3 exposures and we will enlarge those so we can look a little bit more closely at the detail. So here they are blown up a little bit. They're still in the same order, going from 10 seconds to 20 to 30. I'm surprised at the difference that we can see. I really do like the detail on the 10-second one the best, but the color on the 30-second exposure is much greater. And so it's kind of interesting. The 20-second one has been my go-to in the past. But in this case, I think I would shoot for the 10-second one. The color on the 30-second exposure one is a little more red than I like. I like it to look a little bit more natural than that, and I don't know what the difference is. Probably the photons that the higher exposure rate is allowing into the lens. The 20-second one seems a little muted. So if I were to pick out of these, I would select the 10-second one. But, everybody has different opinions. But this was a fun experiment. I'm sad that the 60-second one didn't produce an image. I will have to try it again on another object and see if we can make that work a little bit better. But this is the results. Next up, I'm going to stack every exposure from the subs folder that I have on the Seestar for this object, and we'll stack all those and see what we can come up with. All right, I have the results. All I've done is done all the stacking in the Deep Sky stack. I wanted to do it all inside the Seestar app. I didn't want to do it in serial or anything for this experiment. It stacked 682 exposures, and it discarded one that was in my subs folder for that object. So this is the result. All right, so here's the stacked images. It came down to 217 minutes of exposure. It was 682 actual exposure images stacked together. The image on the left is straight off of the Seestar. I did, of course, crop it so that it's filling the screen because this is smaller than this picture depicts. So I did crop it in the app and I did darken the background, but I didn't do any color enhancing or anything like that. The image on the right is a denoised version of the same exact image. So the one on the left is just stacked in the Deep Sky stack in the Seestar app, and the image on the right is the denoised version. So tell me what you think. I realize that a lot of people do post-processing in other software. For this experiment, I wanted to just use the Seestar app so that we could see the capabilities of the Seestar. But anyway, this was a fun experiment. Hope you enjoyed it. Hope you learned something. And like always, we're wishing clear skies for everyone. Thanks for watching.